In this session, we will learn regarding something called as a acceptance cone. Okay. Now, acceptance cone is basically, it is defined as the angular range, okay, at which the light is entering here onto this fiber, where we have a core, and so this is the core medium, and this is your outer clad. Now, when the light enters the fiber and still propagates through the core by the total internal reflection, and the angle at which it is accepted, so this is the full angle, and this is called as the half angle, okay, or the theta max. So this angle is known as a acceptance angle. Okay, so this light entering this particular angle of theta, so within this range it will be guided through the fiber. If it is going beyond this range, so if the angle is greater than theta, then this will not enter, so light will not enter the fiber, so it will be reflected back outside. So if it is coming out of this angle, let's say it's hitting here, it will come out. Now if it is coming at this angle, then it will go totally internal reflected, and it will pass through inside the core. Okay, so light source alignment must be within this particular angle. Okay, so in let me just take another blank slide. So here also I will explain you the angle of incidence. Okay, now let's say, for example, this is my outer fiber. Now this is my core. Now if this is incident here, and it is getting internally reflected, so this is my core, outer is my clad. Now this is the incident ray of light. Now to this incident ray, this is my normal. Now this is my air medium, obviously, and this is my glass, or that particular fiber medium. Now along with this normal, what is your incident that is creating? So this particular angle, okay, let me just take different. So this is your theta. So the angle that is created between along with this normal to this core, so this angle is your theta angle. So this particular thing is known as a incident angle of incidence. Now we need to understand the another topic that is called as a numerical aperture. Let me just define in this video itself, or in short, this is also known as Na. Now Na defines fiber's ability to gather light, and directly it is related to the size of the acceptance cone, so that we were discussing earlier. So numerical aperture, mathematically it is defined as root of n1 square minus n2 square. So earlier I had also told you, so if this is the fiber, so this is your air medium, and this is your fiber medium. So I am drawing a normal just to differentiate the refractive indices of both of them. Now the angle at which the light is entering here, okay, I was previously I was telling you that is theta. Okay, so that is the theta max. So maximum, if it is beyond this range, if it is going above this, then obviously light will not enter. Only the maximum range at which light can enter, okay, that we already defined before. Now that is maximum. Beyond this, it will get reflected out. If it has to go via your core, then it has to come within this particular range of theta max for it to pass via total internal reflection inside the core. Okay. Now that is governed by, obviously it should be governed by your that theta max. Then the numerical aperture is defined by this n1 square minus n2 square whole root. Okay, and or also earlier I had defined you that one more concept, something called as a critical angle. Okay, critical angle is nothing but it is the minimum angle range of incidence beyond which light gets reflected back. So that is basically, mathematically equation is given for critical angle, we call as a theta c, that is a sine inverse of n2 by n1. Okay, so this is basically your formula for critical angle. Now the cladding is engineered in such a way that okay, in such a way that it has a lower refractive index compared to core. So this is your clad. So I'm calling it as an n2 and this is my n1. So n2 is always lower than n1, then only your light will remain inside this fiber. It will get totally internally reflected, and obviously it has to fall within that critical angle, then only it will get internally reflected. So this is the like basic principle of total internal reflection. So till now I had discussed the like multiple topics. So we discussed regarding the light propagation in optical fibers. Then we discussed regarding reflection. Then we also discussed refraction, refractive indices, numerical aperture, angle of incidence. Then we also discussed the phenomenon of total internal reflection. Then we also discussed critical angle. So these are the basic topics that we discussed. We have also covered what is the acceptance cone. Then we had covered what is Snell's law, how the refractive index is related to the angle of incidence and angle of refraction. So these are the basic key takeaways. From my earlier couple of videos and this video.